So check out this next one. Clearly not linear, right? I mean, that's somewhat obvious. And what we're going to do is fill in the table on this one as well. And when we do, we'll notice a few patterns. But first, let's review a little bit of Math 3. What is the vertex? I'm not asking for the definition of the vertex. I'm asking for the coordinate of the vertex. Vertex on a parabola, that's what this is. This is a parabola. You may want to label it in case you forgot what it was called. The vertex of a parabola is its maximum point or its minimum, depending on which direction it's opening. And in this case, it's a minimum because my lowest point is down here because this keeps on going up forever in both directions, right? So if my parabola goes like this, I have a minimum, see, minimum. If my parabola goes like this, I have a maximum. Okay, so what is the vertex? Well, the vertex is that coordinate right there. I'm going to label it vertex. Kind of a turning point. It stops decreasing, starts increasing in this case. And that coordinate is, well, let's do x first. So 1, comma, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1, comma 9. I'm wrong, by the way. I hope you found out where I was wrong. I did it on purpose. It's not 1, 9, it's 1, negative 9. Okay? What are the x-intercepts? Now, x-intercepts, don't make it harder than it is. It's where I cross the x-axis. So I'm looking, well, here. And I'm looking here. This is the x-axis right here. And so I want coordinates. Now, don't just be like, oh, it's -2 and 4. Yeah, fine, great, whatever. Let's give a coordinate. Let's be mathematical about this thing. The x-intercept is -2, 0. See, -2. And then this one's 1, 2, 3, 4, 0. There we go. And then what's the y-intercept? Well, the y-intercept is this guy down here. And so you might be like, oh, well, it's there. Okay, fine. Where is there? Give me a coordinate. And that coordinate right there is at 0, -8. So 0, comma, -8. All right. So let's start finding the values in the table, and then we're going to notice something kind of cool about it. And clearly it's quadratic. We can tell that from the graph, generally. So let's go to -2 and see what the y value is. And actually, we don't have to. We already see what the y value is. So -2 matches with 0. An x value of -2 gives me a y value of 0. So we'll put that in the chart. An x value of -1 gives me a y value that's down here, right there. Okay. Well, that y value is -5. An x value of 0 gives me a y value of -8. See, we already had that coordinate as well. X value of 1 gives me a y value of, well, my vertex. It's 1, -9. And then if x is 2, then y is right there. There's a little bit of symmetry right there. That's not a coincidence. That's at -8 as well. Okay, I want to show you something cool. Let's slide up for a second. Notice that the first difference was the same. When I say first difference, it may not make sense, but it will in a second. Let's do this. Let's see what happens. Okay, how do we turn a 0 into a -5? Well, we would subtract 5, right? Okay, cool. How do we turn a -5 into a -8? Well, we'd subtract 3. Okay, how do you turn a -8 into a -9? Oh, we'd subtract 1. How do you turn a -9 into a -8? We would actually add 1. Okay, so notice that these are not the same number as we move down here, and these are spaced at consistent intervals, which kind of makes this thing that I'm about to say possible. If these were all random and had random gaps in between them, then nothing I'm saying would make sense. But this has a clear pattern to it. This had a clear pattern. This has a clear pattern. So everything I'm about to say is going to apply. So here goes. The first difference was -5 and -3, -1, 0. Okay, let's do it again. How do you turn a -5 into a -3? Looking at these two numbers. Oh, well, I'd add 2. How do you turn a -3 into a -1? Oh, I'd add 2. Oh, how do I turn a -1 into a +1? I'd add 2. If my first difference is constant, it's linear. If my second difference is constant, it's quadratic. Okay, I'm going to write that down up here. And this only applies if there's a consistent pattern in your x's, but that's going to be implied. So first difference is consistent or the same, then it is linear. Second difference is, that's supposed to be an I, it doesn't look like it, but it is consistent. Then it is quadratic. Now we're not going to go any further, but if the third difference was consistent, it'd be cubic. That would be to the third power. See, notice that this is really negative 3x to the 1, and this is going to be something that is squared, and the next one would be cubed, and then fourth, and that kind of thing. We're not going to go that far right now, though. That's not worth our trouble. What we are going to do is go to the next problem and do the same thing, and we don't have to write the equation of it, by the way. It didn't ask for that. That's an issue that we'll address later in a different type of lesson. So what is the vertex? Well, who knows? Let's find it, though. The vertex is, in this case, a maximum because the parabola is upside down. So when I get to the vertex, you say, whoa, wait, this is a video. You can't hear it. Or I can't hear you. So it's that right there. There's my vertex. My vertex is at 0, 2. 0, comma 2. Cool. Actually, you know what? Let's go ahead and do a little shortcut. I know 0, 2 is a coordinate. May as well go ahead and fill it in. We know it's going to happen, right? What are the x-intercepts? Well, there's one here. One here. So right here, that's negative 2, and that's positive 2. So don't just be like, oh, negative 2 and positive 2. Okay, great. It's negative 2, comma 0, and positive 2, comma 0. And you know what? May as well go ahead and fill those in. Negative 2, 0, positive 2, 0. And then the y-intercept is actually something we already discovered. It's at 0, 2. So 0, comma 2. All right. So let's go over here and fill in the stuff on the chart. And when we do, there's going to be some guesswork, right? It's not going to be exact, and we might even guess wrong. And that's going to be okay. I think there are going to be kind of some halves in there, and that's okay for what we're going to be dealing with. We're just learning to kind of look at this and say, hey, it's a parabola. Let's fill in a table. Okay, so we're not even going to do the second difference thing on this. We're just filling in a table. So at negative 3, when I say at, I mean with an x value of negative 3, my y value is down here, right there, wherever there is, and that looks like it would be negative 2.5. So negative 2.5. Hey, you want a shortcut? Notice how symmetric this parabola is. They all are. But this one is symmetric around the y-axis. So that happens here. So when my x value is positive 3, my y value is still negative 2.5. Okay? So let's do the same thing for negative 1 and positive 1. So negative 1 is up here. And that looks like about positive 1.5. So positive 1.5. So 1.5. And then it kind of comes over here. So that's also 1.5. So the coordinate negative 1, 1.5, and coordinate 1, 1.5 are both coordinates on this parabola. We could do the whole second difference thing. I choose not to, but the big idea was we have remembered what a vertex is, what x-intercepts are, and given coordinates, and we can fill in a table of values. So we kind of see the multiple representations happening here. Eventually, we might find the equation of this, but not right now.